we need to find out the coordinate of the centroid of a triangle. So let's begin by considering a triangle ABC. We will also specify its coordinates. Let the coordinates of A be x1, y1. Then B is going to have the coordinates x2, y2. And C is going to have the coordinates x3, y3. Right. Now, how do we define the centroid of a triangle? To define the centroid, first we'll have to consider the midpoint of BC. So let's suppose the midpoint is at D. Then we also consider the midpoint of AC as well as AB. So let's say the midpoint of AC is at E and the midpoint of AB is at F. Now what we'll do, we'll join point A and point D. We'll join B with E and F with C. Now, AD, BE and CF, these are called the medians of the triangle. So median means the median is the line that divides any side of a triangle into two equal parts. That means AD bisects the side BC. Here, BD will be equals to the length DC. Or in other words, we can say that D is the midpoint of BC. Similarly, E will be the midpoint of AC and F will be the midpoint of AB. Now, using this information, we can find out the coordinates of D, E, F. So how do we do it? So let's first note down that D, E, and F are the midpoints of BC, CA, and AB respectively. Now that's because AD, BE, and CF are the medians of the triangle. Now, the point where the medians intersect, so we're going to call that point as G. So our goal will be to find out the coordinate of that particular point G, because the G is going to be the centroid of the triangle. So the definition is that the coordinate of the point where all the three medians of a triangle intersect is going to be the centroid of that particular triangle. So let us first begin by finding out the midpoints, the coordinates of the midpoints D, E, and F. So the coordinates of D will be, now since we have the endpoints of BC, the x coordinate of D will be simply it being the midpoint. So we'll take the sum of the x coordinates of B and C. So we have x2 added to x3, divide by 2. So that's going to give us the x coordinate of D. And then we add up the y coordinate. So that's y2 added to y3. Now we're going to divide it by 2. And this is going to give us the coordinates of D. Similarly, we can also define the coordinates of E as well as coordinates of F. So now that we have the coordinates of the midpoints of D, E, F, our goal will be to use the condition here that if we have the median AD, then the centroid G is going to divide the line AD or divide the median AD in the ratio 2:1. So that means the centroid G divides AD in the ratio 2:1. Similarly, the centroid G divides the median BE in the ratio 2:1. And for CF, it divides it in the ratio 2:1. This would mean that now we have AG over GD. So this is going to be in the ratio 2:1. Then we have the ratio BG over GE. So that's going to be in the ratio 2:1. And then we have CG over GF. So that's going to be the ratio 2:1. Fine. So this is known to us. Now using this fact, how can we find out the coordinate of center G? So let's consider any one particular median. So we'll start with the median ED. Now here, since we have the point G, which is dividing the median in the ratio 2:1, so we can use the section formula to easily find out the coordinate of point G. So let's do that. So let's use the section formula. Now we'll start by we'll first find out the x coordinate of the centroid G. So the x coordinate is going to be, we'll take the length AG, which is 2 units, and multiply it with the x coordinate of D. So that's going to be x2 plus x3 divided by 2 added to 1 times the x coordinate of A. So that's going to be simply x1 whole divided by 2 plus 1. So this is going to give us, so here 2 and 2 gets factored out. In the numerator, we are now left with x1 plus x2 plus x3 divided by 2 plus 1. So that's going to be 3. So this is going to be the x coordinate of the centroid. Let's find out the y coordinate as well. So here we'll take 2 times the y coordinate of D. So that's going to be y2 plus y3 divided by 2 added to 1 multiplied to the y coordinate of a. So that's simply y1 divided by 2 plus 1. So this is going to be y1 plus y2 plus y3 divided by 3. So therefore, now G has the coordinate x1 plus x2 plus x3 divided by 3, and the y coordinate will be y1 plus y2 plus y3 divided by 3. So you can verify that if we use BE, the median BE, and use the section formula, then the coordinate of the centroid G is also going to be the same. So this is how we can obtain the coordinate of the centroid of a triangle whose vertices are known. Now let us try to apply this particular idea. So we'll try to understand this idea with the help of few examples. So in this problem, we need to determine the coordinates of the centroid of a triangle whose vertices are given to us. So we'll suppose by considering a triangle A, B, and C. So let's suppose that the coordinate of A corresponds to 0, 6. B corresponds to the coordinates 8, 12. And C corresponds to the coordinates 8, 0. Now we need to find out the coordinates of the centroid. Let's suppose G is the centroid of this triangle ABC. Now to find out the coordinates of G, all we have to do is, for the x coordinate, we take the sum of the x coordinates of each of the vertices. So we have 0 plus 8 plus 8, and we're going to divide it by 3. Then we take, for the y coordinate, we're going to sum up all the y coordinates of the vertices. We have 6 plus 12 plus 0 and divided by 3. So that's going to be the centroid, coordinate of the centroid. Let's find it out. So we have 16 over 3 and we have 18 over 3. So 18 over 3, that's simply 6. So we have G 16 over 3 and 6. So this is going to be the centroid, coordinate of the centroid of the triangle whose vertices are 0, 6, 8, 12 and 8, 0. Let's go to the next problem. So problem number 2, we need to determine the coordinates of the centroid of a triangle, and here in this case we are given the coordinates of the midpoints of the side. So let's say we have a triangle ABC, then the midpoints of side BC we're going to denote it by D, the midpoints of side AC we're going to denote it by E, and midpoints of side AB going to denote it by F. Now the coordinates of D, E and F are given. So let's say the coordinates of D are 1, coordinates of E, that's 2, negative 3. And coordinates of F, let it be 3, 4. This information is provided to us, so we need to find out the coordinates of this centroid. So we'll begin by first considering the coordinates of A, B, C, and C. So let's say the coordinates of A being A, x1, y1. Coordinates of B, let it be x2, y2. And coordinates of C, we are going to consider it to be x3, y3. Let's start with the coordinates of the midpoint D. Now, if we know the endpoints of B and C, we can define the coordinates of midpoint D. So that's going to be x2. We're going to take the sum of the x coordinates. So that's x2 plus x3 divided by 2. And to find out the y coordinate, we're going to take the sum of the y coordinate of the vertices B and C. So that's y2 plus y3 and divided by 2. Now it's given here in the problem that this is equals to 1, 1. So equating, we get x2 plus x3 divided by 2. So that will be equals to 1. And we get y2 plus y3 divided by 2. So that's going to be equals to 1. So what we have x2 plus x3. So this will be equals to 2. So this is going to be one equation. We're going to label this as 1. And then we have y2 plus y3. So that's going to be equals to 2 as well. So let this be equation number 2. Similarly, we can define the coordinates of the midpoint E. So the x coordinate is going to be, we'll have to consider the x coordinate of the vertices A and C. So we have x3 added to x1 divided by 2, and the y coordinate will be y3 plus y1 divided by 2. And that's given here the coordinates of midpoint E, that's 2, negative 3. So when we equate this and form the equation, then we'll get the equation x3 plus x1. So that's going to be equals to 4. Let this be equation number 3, and we get y3 plus y1. So that will be equals to negative 6. So let this be equation number 4. Similarly, we can define the coordinates of midpoint F. Now we have the coordinates of midpoint F, and that gives us the equation x1 plus x2 equals 6 and y1 plus y2 equals to 8. So these are the equation 5 and 6. So we have these 6 equations. So we'll begin by first adding equation number 1, equation number 3, and equation number 5. So here we have x1 repeating twice, x2 also is repeating twice, and also is x3. So we have 2 times x1 plus x2 plus x3 on the left hand side. So this will be equals to, so 6 plus 4, that's 10, 10 plus 2, that's going to be 12. So we get x plus x2 plus x3. We're going to divide both sides by 2. That will be equals to 6. Now what we'll do, we'll divide both sides by 3. So with x1 plus x2 plus x3 divided by 3. So 6 divided by 3, that's going to be 2. Next, what we'll do, we'll take equation number 2, add it to equation number 4 and equation number 6, such that we get 2 times y1 plus y2 plus y3. So that's going to be equals to, so we have 8 minus 6, that's going to be positive 2. 2 plus 2, that's going to be 4. So what we'll do, we'll divide by 2 first. So get y1 plus y2 plus y3. So that will be equals to 2. And then finally we'll divide by 3 to get y1 plus y2 plus y3 divided by 3 equals to 2 over 3. Now we have the coordinates of the centroid, because that's simply x1 plus x2 plus x3 divided by 3, and the y coordinate is y1 plus y2 plus y3 divided by 3. This is 3. So this corresponds to 2 comma 2/3. So that's going to be the coordinate of the centroid of the triangle, whose coordinates of the midpoints of the sides are given to us. Let's go to another problem. Problem number 3. It's given here that the 2 vertices of a triangle have coordinates 3, -5 and -7, 4. And the coordinate of the centroid is also provided to us. We'll need to find out the coordinate of the third vertex. So let's say we have a triangle ABC, and we'll assume that B has the coordinates 3, -5, and C has the coordinates -7, 4. Now the coordinate of the centroid, that's also given to us. So that's 2, -1. Right. Now we have to find out the coordinate of the third vertex. That means the coordinate of vertex A. We'll assume that the coordinate is given by x, y. Now that's a very simple problem, because we know that the coordinate of G, which is simply, we take the sum of the x coordinates of all the 3 vertices. So that's x plus 3 minus 7 divided by 3. And the y coordinate will be the sum of the y coordinates of all the 3 vertices. So that's y minus 5 plus 4 divided by 3. And it's given here that this has the value 2, -1. So that means we have x, so 3 minus 7, that's going to be -4. So we have x minus 4 divided by 3, we have y minus 1 over 3. So this will be equals to 2, -1. Now we can equate each of the coordinates. So we have x minus 4 over 3. So this will be equated with 2. Solving for x, we have x minus 4 equals to 6. So x comes out to be equals to 10. And then we have y minus 1 over 3. So this will be equals to -1, which gives us y minus 1 equals to -3. So y will be equals to -2. So we have obtained the coordinate of the third vertex. So that's simply 10, -2. Problem number 4. So here we have a triangle ABC where G is the centroid. We need to show that the following relation holds true. Let us begin by first considering a triangle ABC. Here we are going to name the vertices. So let the vertex of the coordinates of vertex A be denoted by x1, y1. We're going to denote the coordinate of vertex B with x2, y2, and coordinate of vertex C, that would be x3, y3. Fine. Now, by definition, the coordinate of G, so that's going to be x1 plus x2 plus x3 divided by 3. That's going to be the x coordinate, and the y coordinate will be y1 plus y2 plus y3 divided by 3. Fine. Now let's do one thing. Let's try to find out the length AB. The length AB, which can be obtained by using the distance formula. All we have to do is take the square root, and underneath the square root, first we'll have to take the square of the difference of the x coordinate. So since we're considering AB, the difference of the x coordinate, so we're going to consider x1 minus x2. Square it and then add it to the difference of the y coordinate. So that's simply y1 minus y2 whole square. Fine. We'll do the squaring later. We'll keep it aside as it is. Then we can find out BC. The BC is going to be, we'll take the square root. underneath the square root, we need the difference of the y-x coordinate first. So that's x2 minus x3. We're going to square it and then add it to the square of the difference of the y coordinate. So that's y2 minus y3 squared. Fine. And then we have CA. So CA is going to be equals to, we'll take the square root. So underneath the square root, we have the difference of the x coordinate squared. So that's x3 minus x1 whole squared. Added to, we need y3 minus y1. So that is going to be the difference of the y coordinate and then square it. We're going to keep this aside for the time being. Now let's calculate the value of GA. So GA, that's going to be equals to, we'll take the square root. Now underneath the square root, what we need is the difference of the x coordinates. So we'll take x1 and from it, we're going to subtract the x coordinate of G. So that's x1 plus x2 plus x3 divided by 3. And we're going to square it. And we're also going to add it to the difference of the y coordinate, which is simply y1 minus y1 plus y2 plus y3 divided by 3 whole squared. So let's further simplify this. So this is going to give us where we have square root of. So 3 times x1 minus x1. So we'll get 2x1 minus x2 minus x3 divided by 3 whole squared added to 2y1 minus y2 minus y3 divided by 3 whole square. So this is GA. So similarly, we can also find out GB and we can find out GC as well. So now that we have the length of GB and GC, what we'll do in the next step, we're going to square each of the lengths starting from AB. So we'll do AB squared, BC squared, CA squared, and also GA squared, GB squared, and GC squared. So we'll first begin up by adding AB squared plus BC squared plus CA squared. So this will be equals to, so here we have x1 minus x2 squared. So let's expand it. We're going to get x1 squared minus 2 times x1 times x2 plus x2 squared. Then we have, let's add all the terms containing x. So from BC squared, we have x2 squared minus 2 times x2 times x3 plus x3 squared added to the expansion of x3 minus x1 squared from CA squared. So we have x3 squared minus 2 times x3 times x1 plus x1 squared. Then we're going to add all the terms containing y, starting with y1 minus y2 squared. So we have y1 squared minus 2 times y1 times y2 plus y2 squared. This will be added to, we have y2 squared minus 2 times y2 times y3 plus y3 squared added to, then we need y3 minus y1 squared. So that's y3 squared minus 2 times y3 times y1 plus y1 squared. So now combining the like terms, we get 2 times x1 squared plus x2 squared plus x3 squared plus we have y1 squared plus y2 squared plus y3 squared. And we have negative 2 times x1 times x2 plus x2 times x3 plus x3 times x1 added to y1 times y2 plus y2 times y3 plus y3 times y1. So that's the expression for AB squared plus BC squared plus CA squared. And in the next step, what we'll do, we're going to add GA squared, GB squared with GC squared. Let's do that as well. So we have GA squared plus GB squared plus GC squared. Now what we can do, we can factor out 1 over 9 from each of the terms. So if we factor out 1 over 9 from each of the terms, now we are left with, right. Now here, what we'll do, we'll expand each terms by using the identity. That means if we have A plus B plus C whole squared, so that expands to give us A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA. So here we'll have to take care of the negative sign. So that's not a big issue. For example, let's say if we have A minus B minus C, we can use the same formula by rewriting it as A plus negative B plus negative C whole squared. All we have to do is replace the value of B with negative B and C with negative C, and this is going to give us the result A squared plus B squared plus C squared minus 2AB plus 2BC minus 2CA. Fine. So let's use this to expand each of the terms. So we get the following expression. Now what we'll do, we're going to multiply both sides with 9 to get 9 times GA squared plus GB squared plus GC squared. Fine. So here we can combine few of the terms. So we can combine 4x1 squared with x1 squared. And this x1 squared, we're going to get 6x1 squared. Similarly, we can add x2 squared with 4x2 squared and x2 squared. That's also going to give us 6x2 squared. So that means we have 6 times x1 squared plus x2 squared plus x3 squared. Similarly, we can add all the y terms also to get 6 times y1 squared plus y2 squared plus y3 squared. And if we start with negative 4x1 x2, this will get added to negative 4x1 x2 to give us negative 8x1 x2. But there is also positive 2 times x1 x2, which is going to give us simply negative 6. We'll take negative 6 as the common factor. We have x1 times x2. So this will be true for x3 x1 and x1 x2 as well. And we'll also have it for y1 y2 plus y2 y3 plus y3 y1. So these are going to be common factor. Now what we'll do, finally, we're going to divide each terms by 3 from on both sides. So we're going to get 3 times GA squared plus GB squared plus GC squared. So that will be equals to, so this was 6 divided by 3, that's going to be 2. So we had 2 times x1 squared plus x2 squared plus x3 squared. And we also have 6 divided by 3, so that's going to be 2. So we'll also take it as the common factor, 2 as the common factor, to get y1 squared plus y2 squared plus y3 squared. Fine. And from here, if we take divide by 3, we're going to get negative 2. This will be multiplied to x1 times x2 plus x3 times x1 plus, so this is actually x2 times x3 plus x2 times x3 plus we have y1 y2 plus y2 y3 plus y3 y1. And this is the expression that we obtained for AB squared plus BC squared plus CA squared. So then we have successfully showed that the following expression is true, hence proof.